Today, my session topic is know how recommendation systems can drive retail success. So today we are going to see that how artificial intelligence and machine learning, like how retail industry is leveraging the power of artificial intelligence and machine learning. First of all, not the certificates, the punctuality. So you all are requested to be on time. The second one is please keep your cell phones on silent mode. It doesn't mean that you can use those on silent mode. So the third one is very important, feedback. So the today's topic I choose is all because of your feedback. Because in previous my previous session I got feedback that you should show some real life use cases and everything, inspect of all algorithms and everything. So we are going to see some real life use cases of retail industry today. So this is our agenda for today. First, we will discuss about how machine learning is used in how retail industry are using machine learning. Second one is some top super way AI can revamp the retail sector. So here we will see some real life use cases of AI and ML in retail market. Then we will see how a recommendation engine work, and then the demo of it, where we will create an restaurant recommendation system where that system will tell you from which restaurant you should order the food and from where you should go for the dinner. So let's start. So if we talk about machine learning in retail sector, we all are aware of how much data an industry or an process is generating nowadays. We have humongous amount of data in today's sectors. For example, if we see like here we make a lot of data pipelines and data is coming in streaming, so we can see that how much amount of data we are storing in our database and everything. So these data collection process is totally wastage if we do not use them in a good way or a good manner. Uh, as a result, different top e-commerce websites and e-commerce and some retail vendors and companies, they are leveraging data for meaningful insights like the customer segmentation and to whom we can send the push messages and to whom we can send the discount coupons and everything. You might notice that you and your friend is getting a similar discount coupon from Domino's at the same time. So this is where you are lying in the same segment of like customer segment, and you all are getting the same message for particular amount of discount. So nowadays, data proves to be very powerful thing for these industries. Big companies like Amazon and Flipkart and Netflix, they are using recommendation systems to engaging you on their platform. So if I take my example, I used to watch YouTube videos and I decide for watching them for 5 minutes. But after one video, the YouTube recommender system is that much powerful. It gives me an accurate recommendation so that I watch the second video too. And after that, after the whole, when I goes to close the YouTube, I observe that it's already 1 hour. Like I'm seeing videos for 1 hour or the 30 minutes. So this is the power of the recommendation systems in engaging customers. So uh, if I talk about using machine learning in retail sector, Amazon was the first one to use this thing, the machine learning and AI in retail sector. And according to a study, there 25% of increase in sales is because of AI and ML platforms, the service they have provided. For example, we have smart recommendation systems. We have automated some process like chatbots and everything, and we replace human labors for particular tasks. And by doing this, we increase our overall productivity and the revenue. So according to this, the screenshot you are seeing right now, what AI can bring to retail. So this is the survey, US survey. They do a survey for retail industries which are using AI. So according to them, productivity and personalization will help the AI market reach about $15.7 trillion by 2030. And the global market for AI in retail is currently worth $993.6 million dollars and will grow to about $5,000 million by 2022. So, like, it's an amazing thing that in a short time of period, uh, many of the companies will like generate their revenue and increase their revenue by a humongous amount. So according to the survey, different different companies like retail companies, they are using AI for like drive sales and anticipating demand. So this is actually your demand forecasting. We will see those in the like some use cases of that. And second one is understanding customer behavior. So I gave you an example of Domino's right some time ago. So this is where we use customer behavior or the pattern of behavior, how he is buying products or he's selecting the products. So according to them, we can also recommend some of the products or some of the like items to him. Uh, so this was according to survey. And the benefit of AI for retail business worldwide in 2018. So this is the survey of 2018. Uh, it's actually a US survey. So the retail sectors are like saving the cost by 49%, and they increase their productivity by 44%. And these are the difference that's for like how AI and ML is benefiting these sectors. So now let's talk about some superb way AI can revamp the retail industry. The first one is eliminating overstock and out of stocks. So for example, if I live in Noida extension, so whenever I have to buy some product or something, I go to Walmart, and when I didn't get any product there, what I will do that I like open my mobile application for Amazon or any Flipkart, and I check the product there. And nearly 90% of time, I will find that product on that platform. And immediately, if I have bandwidth of 1 or 2 days, I directly order the items there. So we all know that an excess of or the short supply of product can affect the company's profit and the revenue. For example, if we have a lot of amount of resources which we are not using, so it will directly affect our revenue and the cost. It's not only for retail sector; it's for all sector, for IT sector too, which we are working in, and the different sectors. So like leftover stock is often uh, it gives the low sale turnover every time. And on the other hand, if we talk about out of stock, so it also like cost you the some of your customers, you lost your customers, the loved customers, and they can easily switch to the like your rival industry or your like competitor easily. So AI help retailers replenish supplies by identifying demand for a particular product based on their sales history, what they have purchased in the past, the location where you are like staying right now, the weather or the promotions going on that in these areas, and what is the trend. So what is the if I talk about the like Bihar, so there's a trend of eating rice and everything. So you can lower the cost and increasing the productivity in that area and so on. So here we like this use case is known as supply chain management. We all heard about this term, I think. So it contains of different processes like demand forecasting. It's like same as weather forecasting. We see all the parameters or the different things which affect the uh, rise or lower the temperature. Then the inventory planning, how much products you should contain in the inventory. Then the replenishment, like replenishment is how much amount of product you can add or you can reorder. Another use case is adjusting price. For this one, I use a trick on Amazon and Flipkart. Like I used to search for any product and I add them into the cart. And I wait for 1 week or the 2 week and the 1 month. And immediately they give me a push message that this price are lower by 50% or 40%. You can buy it. So this is here this use case is like come into action. The price optimization or adjusting price. So Amazon tell the sellers that there is a heavy demand on this product and you can decrease the price and your profit will not like much differentiate in this process. So this is how adjusting price, like AI is helping in adjusting price. The third one is your product categorization. So many of times it happened that a seller like places his product or anything out of the category. Suppose you are searching for any sports category, he placed the product in the wrong way or the wrong category, and customer or user will not able to find that product in particular category. We also do this thing that like we filter the sectors and areas in our searching area. So like I have searched for like a range of 1 to 1,000 and category as sports and everything. And sometimes what happen is your product is missing from that category. So here the AI is useful. There is one site called lovethesales.com. So what they are providing is any seller can upload the image of their product on that website, and that website will tag the product according to the category, and it also tell you the what should be the price of that product so that you can easily sell them. We all know this thing, the chatbot. So the chatbot for customer support. Like here also we are using chatbot on our website. So chatbot, how chatbot helping you is it gives customer or the user 24 into 7 support. So whenever any user or customer comes to your website or uh, so he will not disappointed by not getting any reply or anything. So chatbots are like very useful in giving support to your user or customer. So another one is voice product search. We all know, like we all aware of like Google Assistant and Alexa. So it's like in trending nowadays. So what this technology do is, so it gives an like voice support for your searching area. So you can say that Alexa book an restaurant for me, and in fact Google Assistant, like Google has given post in like 1 year before that their voice assistant has like passed the Turing test. So it is so like you just say that book an appointment with the doctor, and that vendor or the doctor is not able to recognize that it's an assistant or anything or a real human. As in that, we can see that use of Google Assistant. So Google Assistant works with more than 5,000 smartphone devices. That's included like Sony Bravia, JBL Link, and about 225 brands support Google Assistant. Like if we talk about retail sector, that is Walmart, Costco, H&M, and the Home Depot. Similarly, if I talk about Alexa, so Alexa is supporting over 20,000 devices, and about 3,500 brands are using Alexa for their voice search, like Sony, Pocado, Morrisons, and Johnny Walker. And we all are aware of like Google Lens. So anybody here use Google Lens ever? So can anybody tell me for which purpose you have used it?
To identify the objects.
Yes.
So I just trying to identify the problems.
Okay. Yes. Valid. So you can also use like this Google Lens or any product related to that in your searching the product. Like I search for a jacket, so it will scan the whole jacket, its color, its everything like shape, pattern, everything, and it recommend you the website too. Like if you ever scan a jacket or any product on Google Lens, it will give you options like this is available on Amazon or Flipkart. So this is how your visual product search works.
Is that AI or is that just
This is AI actually. So previously it wasn't like the logic and everything. We are converting all the like array metrics and like seeing the pattern of that image. But now they are like in 2014, convolution neural network was invented by YouTube. So after that, a lot of companies and a lot of platforms they are start using them for like image categorization and classification. So now,
So the primary AI or like machine learning defined would be in the image recognition.
yeah.
That if I'm putting this image whether it is a jacket or something else, and after that it's paid search.
Uh, Actually, it's like these websites like Google and everything. They have huge amount of data.
It's actually basically deducing what features are present in the image and classify like you have classify that image according to those features, and then like if some user comes and selects, okay, I want this black jacket, so we can see what all similar items we have. We'll see in the recommendation system moving forward, so we then can recommend this ahead. So basically AI is used to deduct the patterns from it and find out, okay, all right, I can categorize this picture in like 150 or 160 categories, and when the user comes, we can see what we have in the data set and we can recommend.
So let's like if we see the example or anything, if we train our model on different images or the data set of images, it's like take a convolution from that image, a matrix of small matrix and extract that feature, and it sees that if we train our model on 1,000 jackets, so it will see that how many times that feature is like repeated in the training set, and it will tag that feature with that jacket level, and whenever it like got that in like when we scan this jacket, the new one, the testing phase, it will search for that pattern. So it will go from this pattern, and whenever it matches, it gives the label jacket. The another one is like this is like I was also amazed by this example or this. Uh, So this is virtual fitting rooms and mirrors. So like how many of you are like keep doing shoppings and are great shoppers? Nobody. So like whenever we went for any like shopping or everything for buying clothes and everything, a lot of time this happened that we weren't able to get an empty fitting room or the trial room, and this result in sadness or anything, and customer go back like I'm waiting for half an hour and I'm not getting anything. So here like this virtual fitting rooms and mirrors are useful. Like China is using this in many of the stores, and what they are doing is they have placed in like mirror or any display in like starting of their like entrance, and you just see the jackets and everything in the catalog, and you just drop this on the like dummy structure, and it will also recommend you that if you're buying this shirt, so this jean will also match that product, and it will give the location of that jean and everything also. So how
Lenskart uses this
yes,
fitting mechanism.
Lenskart is also using this. So how it's going to, so it have the RFID technology plus augmented reality, and it's bring the like garment in front of mirror. You have to like another thing is you have to like keep the garment like this, and it will scan the whole thing and your body structure too. So it will give you the fitting size also.
And RFID is for understanding the product.
Just for understanding the. So another one is cashier-free stores. So we like I don't think we have this in India till now, but in US and China it's like this is very common. So Amazon Go and the Alibaba stores they are using this thing. You don't have to like bring your wallet or like money with you. You have to just scan your RFID and like go in and shop. And after that, okay, there is one thing. Alibaba has introduced an like system in their stores. Like whenever you are exiting from the store, you have to give your like face for the exit point, and it will like do an emotional analysis. if you were like smiling at the existing point, they will give you a heavy discount. So no, it's real. Like I can show you. Yes. So here the deepfake also introduced. So,
So where is AI in this? Like if it is cashier-free stores,
yes.
I think that's more like identifying the products that I'm buying.
Okay. So here like there are different like whenever you are like roaming around the store, it will keep an eye on you, the camera. So it will like taken like scanning you and say that where you are going and everything. So they have a database of their customers and they're like matching them whoever is coming or going out and in entry point and exit point they have facial recognition, they have emotional recognition and they also have a like review system, like you can write a review for that product or you're buying or you're shopping and they will do a like a review. They have a separate review system so they can observe that what things are going well and bad. So like these are some internal insights.
Yeah, the personalization and the recommendation that they might be collecting that
Yes.
might fit into that category. That's what it is, like tracking what I'm doing. So we built a similar system for a company called Tyco way back, and in that we use RFIDs.
Yes.
Like with the RFIDs, with the edge nodes, we were able to find out, whether you're taking product along with
Yes.
your
Yes.
so that part is relatively well. I would not categorize that as AI, but maybe personalization recommendation.
Yes, it can be like the RFID part, maybe not an AI, but the exit point you have scanning your face and it catching your emotion and everything. So that part is like purely AI.
Yeah, emotion.
Wouldn't it be easy to game the system to perform?
If they give you discounts, if you smile,
Yes.
we give an ugly smile no matter what.
And like if you give the wrong smile, they are also introducing deepfake, so they can observe the like fake smile too and coming back. So let's talk about recommendation system now. So that is our main topic or main agenda. So over to Rahul.
Hi everyone, morning to the people at the back and evening to the people at the front. Just a quick update, India won by 6 wickets, so you can put your mobile down and we can just quickly move on to the recommendation systems, which is the important part of the day. Let's see, alright, so what is a recommendation system? Can anybody tell me? You can't hear me?
We are recording it recording.
Anything that takes recommendations.
Let's see. Okay. So yes, anything that makes recommendation is known as recommendation system. But this is a pretty layman terms. What we are able to achieve with the AI today is we can recommend a lot of things. Just from your understanding of how you touch, how you feel, as Shubham has shown us the superb examples of the AI, we can recommend almost with the help of these computers and the data sets, we can now recommend from, I would say, your shopping spree to your food stuff and everything. So let's quickly dive into how we can recommend item to the users. We can recommend items to a user which are popular among all other users. So like let's say if I bought this thing, maybe there are like 20 or 30 people more that have bought those things. So the next person that comes will might also like this. And the second one is we can divide the users in the multiple segments based on their preferences and recommend items to them based on the segment they belong to and items they are interacting with. So basically what I want to say is the first part is content based filtering and the second part is collaborative based filtering. In the first part, user mostly don't have a role, whereas the items have much important role than the user. In the second part, we have users and items as well. they are collaborating with to find out, okay, all right, what is a better way. And a better way for a recommendation system right now is to use a collaborative filtering. Let's see how the recommendation system has. So basically it has two things. It's the users and items, and interaction of both users and item will give us a way, a data set that will say, okay, this user like this user like this, and if the X user comes, what is the user that might like. Let's say as I already told you, we recommendation system these days can recommend anything. So you see what's common in here. Amazon is using the same recommendation system to recommend the items like household items, bathroom items, food items, whereas Netflix is on the other hand is using the same recommendation systems to recommend movies. Like you have watched Marvel's Daredevil, so you'll watch Jessica Jones, Gotham, and that's it. Now let's see how. Yeah.
So after watching that on Netflix, I get different ads on Amazon, like just getting twice of bad movies and having environments.
Sorry, I didn't get you. You were watching Batman movie on Netflix. That's really great. Yeah. Yeah.
And after that, when I opened Amazon, I was getting merchandise of Batman.
So
It's actually built in a web browser system. There, AI isn't in a much role, but the cookies are actually much important in here, because then Amazon will take cookies, and I'm not pretty much aware how the backend of the UI work, like the web browsers works, but it's surely about the caches and the cookies that Netflix will save, and the Amazon will get those cookies, and then they will try to figure out, okay, you were watching this, so maybe we can recommend, you are a fan of Marvel, so we can recommend you Avengers superhero DVD and something like that.
so
So whenever you save those cookies, they are readable by any browser.
Yeah.
That is why nowadays every website is asking us to accept it.
Exactly. I mean, you passed this rule. It was long back, I guess, 2012 or 13, where it was mandatory to, just give a pop out that okay, the cookies will be there. You should accept it. The fun fact is, even if you reject it, they'll track you in somehow, and that is
So like
pretty.
the example you have given just now is also a part of the recommendation system. Suppose if I have a new item or new product, I didn't have the past record for the user. So they are using something like a demographic recommendation system. So they are buying the data from the other websites and use them for the recommendation.
Google AdSense, I think.
Yes.
So let's see how can we implement a recommendation system. There are two ways, as I already told you: content based and collaborative based. So as you can see, content based, the user doesn't have much role in it. User just interacts with an item, possibly the just a word document, and reads it. And the next recommendation system will find out, okay, these words were read. Maybe the next item that has much of these words will be liked by the user. But the collaborative filtering system is much more advanced, where it's not particularly on single user, but items and users both are in collaboration with each other to recommend a particular item, or let's say whatever you are recommending.
How is that? How is the similarity between two individuals?
We'll see in the demo, maybe it will clear you. So content-based filtering, again, it's simple. Let's see the demo here. Let's say there is a text A which has London, Paris, London. Text B, Paris, Paris, London. So what we'll do is we'll create a distance between those two. First, what we do is we create a vectors of those, and then we find out the distance between those. Let's say the text A has London, Paris, London, which London has two words. London is occurring twice, Paris is occurring once. The second London is occurring once, Paris is occurring twice. So we created two, like this is a pretty, in layman terms, I would say, again, this is the example, but when we come out to the real world, this is just a two-dimensional like vector, but we can have a very, very large multi-dimensional vector for a single item. So we plot those two vectors, and then we find out the minimum distance. So like let's say there would be one more vector here which would like be very far from here, so we'll recommend all those closest distances we can have the proximity to say, okay, recommend the distance which is very less, which is less than this. So that is how the content-based system is working. Here we are not looking at the user for now. We are only looking at the text, like text A, text B. So basically items that are present. So collaborative filtering again is divided into two things. First is the user-based collaborating filtering, and the second is item-based collaborative filtering. So let's say if the for user-based recommendations based on calculating similarities of two users, but on item-based the recommendations are on the similarities of how two users interact with the item. This is really interesting. It is not about the how the items are similar to each other. Like the jacket, black jacket is similar to the white jacket because they are, both are jackets. But someone who likes black jacket doesn't mean he likes white jacket. So this is the point here. The item-based collaborative filtering is where I'll show you again that jacket doesn't matter, but how the users are interacting with those item particularly matters. So in user based system we can see, okay, the boy likes the pizza, likes the salad, and boy likes the cold drink. So we can say, or cyclist, okay, you can see the user A likes these things, so maybe this is missing out, you can try this also, like you can try coke. Most of the users have liked coke with these two things, so you can try out and you can find out. Whereas in item based filtering we can say, okay, user let's see, user 1 has bought like orange, user 1 has bought apple, and user 2 has again bought orange, and user 2 again has bought apple. So we, for user 3 who's purchasing apple, it is more likely that, sorry, it is more likely that like he or she will like the oranges rather than the bananas or something like that. So let's say we'll now quickly look into one of the algorithms that is used in item based collaborative filtering, which is cosine similarity. So let's say cosine similarity is a metric used to measure how similar two documents or two items are irrespective of their size. So we are not considering their size, the what type of item is, but how similar are in like according to the users. So if we can see, like if someone is quick, like good in maths, they can like solve the formula here, and we'll come out with the summations, and square roots will not go much deep into that because I also don't like maths. Okay, so like let's look at the, yeah. So let's now quickly look at the how cosine similarities is being used. Let's see, we have a maybe this will resolve the Vikas question, I guess. So we have a data set where we say, okay, user 1 has watched the movie Pulp Fiction, like Emmy watched the Pulp Fiction, rated 4. Amy watched The Godfather, rated 5. Calvin watched Pulp Fiction. Robert watched Forrest Gump. So we have somewhere around 5 users, and we have a data set of 3 movies, and we have already seen like, okay, what this user has rated the movie itself. So we create a this is like a sparse matrix here. We where we will now try to find out, okay, if how much is relevant Forrest Gump to the Emmy, because Emmy hasn't watched the Forrest Gump, but Emmy has watched Pulp Fiction and The Godfather. So what we'll do is, the approach here is, first we'll find out, okay, we'll create a vector where we will say how many people have the same taste as Emmy. So Emmy has watched Pulp Fiction. How many people have there? How many people are there who have always like has the same taste as Emmy? I mean, is like how is where sorry, we are trying to figure out how the Pulp Fiction is related to Forrest Gump. I'll just mess up here, sorry. How is Pulp Fiction related to Forrest Gump? Basically how two items are similar based on the user's interaction. So we'll see, okay, how many of people have like watched the Pulp Fictions. We'll create a vector 1 v1, which will say like C is for Calvin, R is for Robert, and B is for Bradley. So it's a Calvin has rated 5, Robert has rated 3, and 1 Bradley has rated 1. So it's like Pulp Fiction, the thriller drama. Bradley doesn't like more of the thriller. So we create a second vector which says 3C. So basically Calvin has watched Forrest Gump, Robert has watched Forrest Gump and Bradley has watched Forrest Gump. We are not taking David into consideration here for the this example because David hasn't watched Pulp Fiction. So we create the we use a cosine similarity formula which I already showed you before, and we found out okay the Pulp Fiction is related to Forrest Gump by 0.792. So what does that means is Pulp Fiction, and if someone is watching Pulp Fiction, you'd probably recommend 79 or 80% of the time to the user the Forrest Gump, and the user will like it. So coming out to those formulas, we create a sparse, we just fill up our sparse matrix which says, okay, the Pulp Fiction has relatability to Forrest Gump in this way, Forrest Gump has relatability to, Godfather in this way, the Godfather in this way. Then once we have this data, we then can start on the recommendation. We can then say, okay, Amy hasn't watched the Forrest Gump. What is the probability that how much stars will Amy give if I recommend her or him the the Forrest Gump movie? So we can see clearly according to our calculations, if Amy has liked Pulp Fiction, given good Godfather 5, it will probably she or he will give like 4.5 to Forrest Gump, and that is a good rating out of 5. I mean, for movies to come anything above 2 or 2.5, again you can have a threshold there which will say okay, don't recommend until it's 3 or don't recommend until it's 4. But most of the recommendation system, since right now we still are in a developing phase of the data science and we are collecting data, so we keep the thresholds very low for now, and we say okay, let's try this out scenario and let's try these things and see what better works. So here we can see, okay, let's see if you can see the Bradley won't like Godfather even if I try to recommend him, and like similarly David is a guy who doesn't like movies. You can maybe deduce from that, so he'll probably give 2 or 2. So we can here this recommendations will help us in user segmentation, more content filtering, like better content filtering, and lots of things basically. So we'll quickly look out the demo notebook. Maybe Shubham will help us out. Thanks.
So I can see a lot of cases saying that a lot of theory and everything. Let's go to the code. So a little bit of theory too. Like so for this demo part, we are going to use a matrix factorization or latent factor collaborating filtering. So anybody here can explain the factorization? I guess in basic terms. Anybody? It's in like common term factorization. Exactly. Exactly. So, for example, if we have like 4 times 6 is equal to 24. So we are like distributing our big number into 2 parts. So that's how our latent collaborating filtering works. For example, we have rating of a user for hot dog is equal to 11. So we will distribute the whole of the matrix into 2 parts. The first one is the user matrix. The second one is the item matrix. Then we will do the cross product or the dot product and take out the meaningful like result from that. For example, we have a rating for that girl is 1 and 4, and we multiply it with the hot dog, we get the 11. So this is the likeness of a user for the product. So we are going to use a like data set from Yelp. Anyone know the Yelp platform here?
Yelp is basically Zomato of US.
Yes.
Or like
So Yelp is in like the Zomato of US. So they are containing all the reviews for restaurant and items and everything. So we are going to like use that data set. Is it visible at the last? Okay. No? Okay. So too much. It's too much now. No, it's good, I think. So for this project, like we are going to use NumPy and Pandas. I think everyone heard of these terms. So these are like basic libraries for data processing and some actions on data. And we are using Seaborn and Matplotlib. So these are like visualization libraries, and we are using scikit-learn. So I hope everyone heard scikit-learn. So this is a library for machine learning part. So we are using train test split. So uh, it's important to test our code or everything, what type of result it's giving. Like here also we are doing a lot of testing part, integration part and everything. So it's like important to test our outcomes. And then I'm using NLTK, that's an natural language processing library for text processing and text mining. Uh, okay. So we have imported two data set. We have two data sets here. The first one is Yelp Review Arizona. So here we have review ID, the user ID, the business ID, and the review, and the number of stars and user give on the particular date. So we are going to first is the data visualization or data, we have to see what type of data it is. Like every data has its own storytelling. So the part of data scientist is we have to see that storytelling and give this to the machine learning engineer so that he can produce a meaningful model for the prediction part. So then we are using the data set. Here we have review ID, the user user code or any given ID given to the particular user. We have business ID, and we have this type of review from the user, like time for lunch, especially this much good, sushi and anything, product and everything, and the number of rating he has given to the restaurant. So here we have six features, as I told you, the number of stars they have given, the text and everything, and we have about 26,000 reviews for different restaurants and the users given by the users. So
Sorry, there were six features, or are we choosing six features out of the?
there are six features. So the first one thing is we have to choose what features are important for my data processing or data science. So we are choosing four things: business ID, user ID, the number of stars given to this business, and the review. That is our statement. So we are simply removing the punctuations and stop words. So stop words are like and everything. These all. So we have created a function for text processing. So here we have converted our whole text into particular words or tokens, and see that those are present in stop words or anything else. So if you see that we have imported stop words and word tokenizer here from NLTK. So NLTK is helping us to dividing our statements into tokens, and from directly importing the stop words from NLTK, we can compare our text with the stop words. So NLTK stop words is a collection of different stop words and everything. So we can also filter them. Like there are many more libraries or the functions for that.
So we are using the standard stopwords which NLTK defines, or are we using our own stopwords?
No. We are using the standard stop words. You can also make your own stop words. So in every data science task, there is an important stage, that is data cleaning and data pre-processing. And according to a study, 80% of time of data scientists, he is busy in doing data pre-processing and cleaning. So this is the important role for a data scientist. Here we have apply text process function on every review, and we have convert our data set into 85% for the training part and 15% for the testing part. Because it's a NLP project or NLP task, or if we have uh, data set of numbers and images, we will take 70 to 70 by 30 ratio, because their testing part is more important for large numbers. Uh, so in that screenshot for factorization, I have told you that we have to convert or make two like matrices. First one for the user, second one for the item. So here we are creating two things: user like matrix and the business matrix. We have taken user ID and the review, and we have taken business ID and the reviews for that particular business. So we can see it here, like for a particular user, we have this review, and we have like for particular business, we have this review. So after that, like we have like imported TF-ID vectors. So TF-ID vectors is a like scikit-learn gives us. So what it does it like it create a matrix for us and keep the important features from our text. So it will like give the tags for every word or every data present in that review, and it will take out the important tags for us, like the features. It will create features for us, feature matrix. So let's see it in action. So simply we have like imported TF ID vectorizer. So we have to give the tokenizer. If you like observe, we have imported word tokenizer from scikit-learn in the very first part of like this demo. So we will just pass this the tokenizer, and we can also define that I want 5,000 features or I want 10,000 features. So it will give you a number of features accordingly. For example, we have factorized our business ID like metrics. So it gives us like there are 1411 like restaurants, and it gives 5,000 features for those restaurants. So we have to see the matrix. So here it is. So this is what TF-ID vectorizer gives us. So it gives us like the user ID, the business attributes, and the rating as in data. So from here we can see that which user has given a rating for which restaurant. It might be not visible here rating its NAN because we have large amount of data. It might be in the last column or the middle columns. So after that, we have created two matrices. We have flattened our data or the like matrix into the array. So so that we can easily use that or map that. If we have to see that these are my like business ID restaurants and these are my like, feature number or everything. So we have like anybody heard about gradient descent? The gradient descent. So if I have to define the gradient descent, for example, as a child, we have an like initial parameter. So we have no learning, not everything. So we have like the blank mind and everything. Uh, as the life increases, we learn the processes. We start learning by walking. So we like fall many times, and we learn how we should walk so that we should not like fallen down. So it's the same thing like gradient descent too. Like in my previous knowledge also we see how neural networks are working and how gradient descent are used in that. So if initially we take a value and we see that how much like near it is with the original value, and it like there is some functions and mathematical formulas which like in every step they keep the error minimized. So this is how gradient descent optimization works. Like for with the word optimization, you can think of that process. So here we have defined the number of steps, and we just take every index of our matrix, two different matrices, P and Q. You might amaze that what is gamma here, gamma and gamma. So gamma and gamma are here the learning rates, uh, uh, like on which rate we should like move our value to the near part so that we can learn like in precise way. If we give the gamma or learning rate greater or lower, we will encounter with overfitting or the like underfitting. So you can they cannot map the features with your like data. It might be like for an Italian restaurant, it has the feature Italian food, and if we give a larger learning rate, it might be happen that number of uh, like we our program will take a long step and skip that part. Like we didn't have the Italian food feature for the Italian restaurant. So after doing this uh, gradient descent optimization, we have like this P and Q, and these are our features like breakfast, snacks, eggs, browns, food, bacon, toast, hash, and everything. So I am not training my model here because it's take nearly 1 hour or one and a half hour. So I just pickle my model. So you can pickle your models by importing pickle. So you can give it to anybody else. So we can also work on this like predictive part. You can just pickle your model and send it by any medium, and he can also use that thing. So, for example, we have to predict, like I want to have a dinner with Italian food. So it will give me the recommendation, like there is a restaurant UD90 which have Italian food and everything, and let me,
So in this way, user ID as one of the features.
yes.
Why did you pick user ID?
Because we have to see that how many, like we have number of restaurants, we have number of users. So we have to see that which users have given the rating to the particular business or not. It might be happen that we give the feature NAN and everything. So NANs will confuse our model while training part.
Basically, I think see whether we have different user rates, a user can give multiple ratings. Yeah, no, I could see the reason for getting a user ID if this engine was personalized for a user. So, for example, like Ravi is asking for South Indian, then after you already know his case and probably that is where it becomes important. But in this one, you can just look
Okay, okay. So we have to see that in collaborating filtering, Rahul has showed that we have like give recommendation based on items, but it also involves the user.
Yeah, no, I get that. I get that. That's why I'm asking that in this example that you're showing.
Yes, we are using the user ID too.
We are.
Like
Because I'm just giving that input text. Is that related to that one user? Is that one user ID linked to that text that you just gave? So this one, I want Italian restaurant.
okay, let me tell you that also. So I have given this string. I want to have a dinner with Italian food. Then I apply my all the process, removing punctuation from particular text and everything. Then I have use uh, like the Q matrix. Q matrix, that is our restaurant matrix actually. So okay, you are talking about the user matrix. So the user matrix is used for our training part only, not for the predicting part. So
Yeah, even there, see, if you're not relating it to the user, even for the training, if I know the restaurant and I know whatever the rating against the restaurant, I think that should be enough for this use case.
uh,
Unless I'm missing something.
actually the thing is same for the training purpose. We have to see for example, Rahul has showed that there were the movie data and we have the users,
No,
three
I get
users
that.
and
So,
eight.
yeah, I get those parts. So, because I mean, the user ID is being used for identification, right?
Yeah.
One user can like rate from multiple restaurants, sure, right? So, if you apply a finance program or a kind of to categorize, right? Like in those buckets, what would be the average? What would be in those buckets? Those would be the users, right? In this bucket, we have these users. In this bucket, we have these users, right? Here also, yeah, but so I get that part. So what we are saying is that with the training data that or the training data set that we have used, if instead of this example that you are showing, if we wanted to make a user specific example, then that could have been done as well.
Yes, we can do this.
Yeah, okay. Then it makes
This
sense.
this again is an item based. We aren't using the user based.
So
Yes, we can do that.
We can do this.
Basis of what you're showing right now, probably I could do it without the user as well. Like this part, at least this example. But if there's another example in which say like you as a user, want to go for a certain kind of a restaurant in which you are grabbing the user
Not-
credentials as well, or the user ID as well. Then it
Not
becomes-
exactly, because right now, if you could just, if you could just move down here, we are recommending the stars also. Like, if this Tutti Santi is an Italian restaurant, how much is it relevant? Like, what has user raised it? We cannot just, yeah.
User ID is not relevant.
It is not relevant to the user.
User ID is relevant to club the businesses.
Okay.
I don't know. Yeah. So
Maybe
if
we
you
have to
do
take
that,
it
I could on the same training data set or on the same set. I could give you a user specific recommendation as well. I'll buy that. That makes sense. But if you tell me that, like for this example, you need the user ID, I have a hard time understanding that because for this example, according to me, you don't need the user ID. If you just take the restaurants, if you just take the ratings, if you just take the recommendations, I think that feature set should be enough for this example.
Actually, like in the previous tabs, we have used user ID for like creating two matrices. Like we have used a user matrix, and we have used there we have used user ID for clubbing all the reviews by user. So we have like we have an like
Yeah, I do understand what you're trying to say, that you as a as a business would need a user based recommendation where we can target a single user on his personal or his or her personal
Yeah, I
choice.
just in this example that you're showing.
Yeah,
Which makes
maybe,
sense, by the way,
yeah.
which makes sense. So what you could say is that maybe currently the example that we're showing you is not user specific, but if you understand who the user is, you'll be able to make a better recommendation for him as well because you have the user input as well.
okay. So like like this is like true that we can use it by without user ID. But like in recommendation system, we have like three generations. The first one is like for the dump logic. The second one is for like our basic factorization and everything. The third one is for totally machine learning and deep learning, where our neural networks come in place, like our LSTM and everything. So like there are multiple ways of doing that. So there we have a like strong demand of the user ID.
Sure.
Yes. So like there are multiple of ways for making recommendation system. So like similarly, if I it's like so then I will say that I want to have a dinner with beautiful view. So let's see if it works or not. So it is giving us the restaurant name and like giving us the number of times the review has given for this restaurant. And we have to like check this restaurant whether if it is giving a good recommendation or not. We can just like search it. So like if you see the pictures and like images of this restaurant, there are like totally beautiful views of this restaurant. So like our like model is using like wrong like predicting with good accuracy. So uh, so this was like all about our today's session. Like thank you guys for the joining and thank you knowledge team for the support like last minute changes of everything. So thank you guys.